Yeah, so hi guys. In this video, we are going to solve this problem. This is our fourth problem in stack. The problem is saying stock span problem is a financial problem where we have series of end daily prices stock and we need to calculate the span of stock price for all end days. What it mean to say is I will explain you with the help of example what is the problem exactly, right? So this is the array which is given to us. Hmm. Now what does span means? Like for any element, let's say 75, uh, or any element, if we are saying 75 is here. So the stock span for this element would be uh, all the elements which are smaller in a consecutive order. The number of elements which are smaller or equal in consecutive order. For so for 75, 60 is smaller than 75. Uh, 70 is smaller than 75, 60 is smaller than 75, 80 is greater than 75. So for this, the stock span would be 4. Three elements are smaller and one is this the element itself. So we have 4 uh, stock span for this element. So we will derive the stock span for all the elements first. So I'm writing the elements again here, right? So these are the elements. So at first we are here, right? The stock span I would write here. So for 100, there is no element on the left side. There is no elements on the element on the left side. So the stock span would be 1, right? Because of this element we are also including the element, so the stock span for this element would be 1. Now we are at here, right? So we will see on it left side. So the element is greater, है ना? So we only have this element here, so the stock span would be 1 for this element. Now we are here. The stock span for this element 60. So do we have 80 smaller than 60? No. So we will the stock span would be 1 because of 60. Now we are here. Now we are here. We will check if 60 is less than 70. Yes, it is less than 70. We will check if 80 is less than 70. No. So that means the span is 1 and 2. Now we are here. Right. So we will see if 70 is less than 60. No. So the stock span would be 1, है ना? But if you will see the element 60 के तुरंत लेफ्ट में 70 था, है ना? तो हमने इसको 1 लिखा, बट इसके लेफ्ट में एक और 60 था, है ना? सो वी आर ओनली कंसिडरिंग consecutive smaller elements on the left side. ठीक है? Now we are here at 75. We will see if 60 is smaller. Yes. 70 is smaller. Yes. 60 is smaller. Yes. 80 is smaller. No. So the we have three elements smaller than 75. So the span for this element would be 4. Now we are here. We will see this is smaller than 85. Yes. This is smaller. Yes. This. Yes. This. Yes. This. Yes. This. No. So how many elements do we have? 1, 2, 3, 4, 5, and 6. So the stock span for this element would be 6. So this is our answer. 1112 146. triple one, two one, four six, as you can see. Now if you clearly observe this pattern, so we are at 100, है ना? So there is no greater element on its left, है ना? So what we are doing, we are traversing in the left side and finding the element which is greater than the actual element, है ना? So in the last question we solved next greater element problem, where what we are doing, what we were doing was, we are given an array, suppose 1 3 2 4, है ना, and we have to identify the next greater element for each of them, right? So if I say for 1, what is the next greater element? 3. For 3, what is the next greater element? 4. For 2, what is the next greater element? 4. And for 4, what is the next greater element? Because there is no element, so it would be 1, right? So here we were finding the next greater element on the right side, right? And in the stock span problem, we are given this array. We are given this array and we are finding the next greater element on the left side. We are counting the number of prices which are less than the current price up till we find the greater element. So for each element, we are finding the next greater element. Let's say for 100. Now, because there is no element on the left side, the result is 1. Now we are at 80. So 100 is the next greater element for 80 on the left side, right? So we will stop here and the output will be 1, right? Now we are at 60. Now for 60, the next greater element is 80. Now on the left side, so we will stop here. Now we are at 70. So the next greater element on the left, we will go left, we will see 60 is not greater than 80. uh, Sorry, 60 is not greater than 70. So what we will do, we will not consider this element. What we will do, we will pop this element from stack. Now we will pop this element from stack and we will go to the next element. We will see 80. Yes, 80 is the next greater element for 70 on the left side. So the output would be 2. Right, now we are at 60. Now for 60, the next greater element on right, sorry, left is 70 only, right? So we will write 1. Now we are 75. We will see 60 is not the next greater element, 70 is not greater element, 60 is not greater element, 80 is the greater element, right? So we are counting up to this. So how we are deriving these values, we will say, the current index minus the uh, index of the previous greater element. There we were speaking of next greater element, here we are doing previous greater element, right? So what would we do? 5 minus 1, which is 4. Now we are at 6. 75 is not the previous greater element, 65 is not greater a previous greater element, 70, 60, 80, 100 is the previous greater element for 85. So 6 minus 0 is equals to 6. Right, so I hope you got some overview for the problem. Now we will write some pseudo code how we are going to implement this problem. I'm writing the element one more time, right? And the indexes, right? So what we will do, hmm, we will traverse it from I is equals to 0 to n. In the next creator element, we were traversing from n minus 1 to 0. Here we are traversing from I0 to n. And what we will do, we have to find the next, sorry, previous greater element. So we will say, we will have the stack. Hmm. Uh, First, I can give you some overview of the dry run so it would be more clear. Hmm. So this is our stack, right? And this is our let it be like this, yeah. So the I is here, right? So we will see there is no element on the left, or the stack is empty. We can see, but the stack is empty. So for this, we will write the answer as 1, and we will push push the index of the element. We will not push the element but the index, because we have to uh, identify the span, the difference of indexes. Now we are at here, I is here at 1. We will see if this element, sorry, we will check if 80, sorry, the stack dot peak, if stack dot peak is greater than current element ARR of I. No, so at peak we are, इसको भी ऐसे लिखेंगे है ना, because we are storing the index. So ARR of st dot peak means 0, 100. 100 is greater than 80, right? In this case, I will write this here. Hmm. So in this case, you can see 80. Hmm. The current element is 80 and st dot p means 0. At 0th element we are having 100. So we will what we will do, we will say answer of I would be I minus st dot peak. Hmm. Difference of indexes. Now I is 1 and st dot peak is 0. 1 minus 0, 1. And we will push the index of this element 1. Now we are here. Now we are here, and we will see if 60, this is one case. Now we will see if 60, 60 is here, ARR of I, and st dot peak we have 80. Yes, so it is greater. So what we will do, we will write I means 2 minus 2 minus 1, which is 1, right? And now we are at here, right? So at 3 we have 70, element is 70, and we will also push the element into the stack. Hmm. Now, hmm. Now we are at 3. So ARR of I is 70 and peak is 60, right? So this is not true. This is not true. So if this is not true, it means if ARR of uh, I is greater than or equals to ARR of st dot peak, then we will say st dot pop. Hmm. So the element we were having 70. Now 70 is greater than equals to st dot peak 60. No. So we will pop this from the stack. Now we will again check if 70 is greater than equals to st dot peak. Now peak we have one, which is 80. So we are at 70, right? And this is false. Now here this is false. So we will not pop any more element. We will check this condition. Now the st dot peak element is 80. So 80 is greater than ARR of I, which is 70, right? So the difference of the index is 3 and the peak minus 1, which is 2. Now we are here I. And to populate it, we will push 3 in the stack. Now we are at 3. We will see if 60, the 70 is greater than 60. Yes, correct. So 4 minus 3, 1. Okay, now we will push this into stack. Now I is 75. We will see if this element is greater. No. So we will pop this element. We will run a loop until the st dot peak element is smaller. We will keep popping the element. This is smaller, we will pop this. 4 is popped. This is smaller, 75, we will pop this. And after that we have 1. This is smaller, no, this is greater, right? So here we will stop, and the difference we will see 5 minus 1, which is 4. And we will push the index into stack 5. Now we are here. Now we are here 6. So we will see if 85, the element added immediately, the stack peak element is greater. Is 75 greater than 85? No. We will pop this element. Now we will go to 1. We will see if 80 is greater than 85. No. So we will pop 1. We will see if 100 is 100 is greater than 85. Yes. So 6 minus 0, 6. This is how our code will go, right? So let's quickly write the code for the solution. I prepare it ARR. So we will write int n is equals to ARR of length, because we don't have n here, and we will have an result new int of n and stack new stack stack. Now we will say for int I is equals to 0, I is less than n, I plus plus. We will say while stack is not empty and ARR of I is greater than ARR of st dot peak. You say st dot pop. When this is done, if the stack is empty, the stack is empty, we will say. Now here is one uh, scenario, special case that we missed, like when the stack is empty after popping all the elements. If the stack is empty, it means all the elements are smaller, you know. It means all the elements are smaller than ARR of I. So in this case, what we will do, we will say ans dot I, not ans, we are having result of I equals to I plus 1 if the stack is empty. If it is not empty, we would say ans of I is equals to I minus st dot peak. Hmm. And at last we will make a push to the stack, index push. Let's try run this, sorry, run for this test case. Test case. Okay, here also I mentioned ans. Yes. Okay, missing return statement. I should return res. Okay, sorry. Yeah, so the output is correct. I will give you an example of this so it is fast, right? So suppose our array is something like this. Our array is 100, 60, 40, 180, 60. Now for this element, you will see, you will not find any like, you will see this is smaller, right? We will have the index in the stack of all these elements. 0 1 2. Now because this element is not smaller than this, now 40 is smaller than 180, it's not greater, right? The previous greater element is not 40, not 60, not 100. So you will pop these indexes from the array and your stack would be empty. Now in this case here, now so in that case the answer of I, or the stock span, would be I plus 1. I plus 1 means 3 plus 1. 3 plus 1 which is equals to 4. Now, in that case, you have to give the span as 4, 4, not 1. Now, because you will say all the elements are removed, stack is empty, so we can keep it 1. No, we cannot. Because if we pop all the elements, it means the in stock span those elements should be included, right? The previous creator element, if you will see, is at -1 index. Now it's not there in the array. Yeah, so I hope you uh, got the idea for this problem. So thank you for watching. Bye bye. Okay.